Right. Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, our beloved students. Let us begin. We shall begin with a recap briefly of what we looked at the other time. Our discussion in chemistry, we had looked at the reaction of chlorine with water to form chlorine water and the effect of sunlight on chlorine water that we concluded. And we made a note of the following: that one, chlorine water is pale yellow, urine color. When exposed to sunlight, it decomposes and gives out oxygen. And because of that oxygen, there is a bleaching effect that it produces. And we noted that one application of chlorine in water is the water treatment, where chlorine dissolves in water to form hydrochloric acid to kill the germs, and hypochlorous acid that bleaches, removes the color and the bad smell in water. The same effect was manifested when we looked at the reaction with sodium hydroxide. And we had two major effects. The reaction with the sodium hydroxide, when dilute, cold, and when concentrated, hot. But again, one common thing that came out was formation of bleaching agents. With sodium hydroxide, which is dilute and cold, we formed sodium hypochlorite, a relative of zinc. With the concentrated sodium hydroxide, we formed sodium chlorate, a relative of Vim, something like that. So in these two reactions, we're dissolving chlorine in water and chlorine in sodium hydroxide. And I requested you to go to the portal, to the website, download the notes so that we can move relatively faster. So when you read ahead of the teacher, discussions become easy and you can be in position to follow. Therefore, this morning, I'm glad that we're going to continue with the reactions of chlorine, this time reactions of chlorine with hydrogen. I want you to remember that hydrogen, the periodic table, takes position 1. And therefore, it is in a family of metals. If it's in the family of metals, a group 1 element, we expect hydrogen to readily react with chlorine. Remember, these are two substances, two elements found on either side of the periodic table. Hydrogen is on the metal side, chlorine is on the non-metal side. So we expect a simple reaction to take place in between these. And if I want to take you back to bonding, there was bonding that we shared in senior 2 between hydrogen and chlorine. And if you recall, we agreed that hydrogen with 1 electron reacts with chlorine, and chlorine has how many? It has 7 electrons in the outermost energy level. So if these are the 7 electrons in the outermost energy level for chlorine, if you remember very well, these are 8 and these are 2. Electron configuration 2 to 8 to 7. This is 1. We say that these 2 can come together by sharing electrons. So if they are to share electrons, our product is going to be, this is a hydrogen atom. Next to it is now a chlorine atom, if you remember. And therefore, these are the 2 electrons inside the chlorine energy level, which is energy level number 1, followed by 8 electrons in the second energy level, followed by 7 electrons in the outermost energy level. These are the 7 electrons. But hydrogen has also contributed 1. So if hydrogen has contributed 1 electron, Therefore, we have this as X. And if you remember very well, we said hydrogen is interacting with chlorine to form hydrogen chloride with a single covalent bond. I am therefore bringing in this idea to predict what's going to happen there. This reaction takes place readily. Therefore, what am I trying to show you? I'm trying to show you that hydrogen reacts with the chlorine to form a certain compound which is called hydrogen chloride, which is seen here. I am illustrating using senior 2 chemistry so that we can move together as one. So I hope you have remembered using senior 2 chemistry that this reaction is going to take place. By the way, this reaction requires that what do? You burn. So when you pass hydrogen, chlorine over hydrogen mixed with the chlorine, and you burn, the two are going to give us hydrogen chloride. So as chemists, we want you to remember that the formula for hydrogen is H2 reacting with the chlorine, which is also a gas. So our product for this reaction is what we are calling hydrogen chloride, and hydrogen chloride is a gas. We need to balance the equation. There are two hydrogens here. So here hydrogens are 2, chlorines are also 2. Here hydrogen is 1 and the chlorine is 1. In balancing this equation, we shall try to make the odd numbers even so that they are equal to this one. So since this is 2, this is 1, this is 2, this is 1, how do we make these two odd numbers to be even? The simplest number we can multiply by this 1 to get an even number, which is as low as this one is a 2. Therefore means in the balance of the equation, we put a 2 there, it becomes a balanced equation for the reaction. Conditions for this reaction requires that burning must be done. Therefore, without a source of heat, this reaction cannot take place. So hydrogen chloride, if they want to ask for an observation, is seen as white fumes. So observation, the pale yellowish greenish gas burns in hydrogen to form white fumes of hydrogen chloride. So we are ending up with white fumes of hydrogen chloride as a product for the reaction. And if you check the notes that I asked you to go and download, we shall have the following: that when a jet of burning hydrogen is lowered into a jar of chlorine, it continues to burn, forming steamy fumes, white fumes, and these white fumes are white fumes of hydrogen chloride. So there is an equation for you in the notes, and the notes continue to say, a mixture of hydrogen and chlorine also explodes when exposed to bright light. So the issue of explosion is not the very important thing. The most important thing is the equation that has been formed and balancing it. And thereafter, there is a small diagram to show you how the burning is supposed to be done. Therefore, in your notes, what happens? You have a container that has chlorine in it. So what happens is that a delivery tube bringing hydrogen into this chlorine has been drawn. And at the end of it all, what happens? This is hydrogen coming in. When you light hydrogen in the chemistry, hydrogen readily burns with a yellow flame. So when you light the hydrogen and lower it here, there is going to be a flame that's going to be formed here. And therefore, for you, what will you see? You will see white smoke coming out of this place. So the pale yellowish green gas that was inside this container will turn into white fumes because of formation of hydrogen chloride gas. Of all the properties of chlorine, this is one of the properties that we do expect you to be in a position to remember. So please capture this property. We need it. Number one, chlorine and water. Number two, chlorine and sodium hydroxide. And number three, chlorine and hydrogen. So I want to just know that chlorine, hydrogen bonds in chlorine to form white fumes of hydrogen chloride gas. And if you remember senior 2, I want to repeat, under bonding, we saw hydrogen contributes and shares electrons with the chlorine to form hydrogen chloride, and the two are bonded together using a covalent bond. So this one we captured. So I want to stress that just know that the hydrogen bonds in the chlorine to form white fumes of hydrogen chloride, and this is our balanced equation. If you want the experimental setup diagrammatically, it is scripted here but found in the notes. So we shall move to the next property. The next property of hydrogen that I want us to look at, depending on how we arranged our work with you, if you have downloaded the work as requested, was hydrogen, which is going to act as an oxidizing agent. And there are so many things to look at here. Number one, I want us to consider reaction of hydrogen with chlorine with hydrogen containing compound. So with hydrogen containing compounds. And under this category, there are quite a good number that we can look at. It includes things like hydrogen sulfide. Remember, this gas has a smell of rotten eggs. The formula for hydrogen sulfide is H2S. It involves a reaction with ammonia. The formula for ammonia, if you recall, under nitrogen was NH3. It involves reactions with hydrocarbons. So what is a hydrocarbon? Hydrogen and carbon formulae. So there are so many hydrocarbons, quite a good number of them, ranging from alkanes to alkenes, alkynes, and so many of them. Any hydrocarbon that you can think of. So don't get stuck. Somebody gives you a CH4 is a hydrocarbon. You can figure out and get the product. Somebody says, no, I want to talk about the C4H10. You can still figure out and get the reaction. Somebody says, this time I want a C10 and H16. You can figure out as long as there is carbon and hydrogen. So those are three important reactions that we expect our learners to have an idea. But now, in all of these, you can easily guess and see the products of formation. Remember, chlorine and hydrogen, those two are always madly in love. So wherever there is hydrogen, chlorine will always pick it. Which means there is always a parallel reaction between hydrogen and chlorine. In whichever form the hydrogen is, it will be picked. I do expect that now my students, wherever they are, they can tell me what will be seen when chlorine is passed through hydrogen sulfide gas. The key point is hydrogen will always be picked by chlorine in whichever form it is. So what do you think will be the observation? To get the observation right, you must figure out the type of reaction that's going to take place. This is what we call displacement. Hydrogen is married to sulfur, but the family is a stable family in the absence of chlorine. The moment chlorine comes in, disorganizes the marriage. Hydrogen says, no. The fella I want is chlorine, but not what? Sulfur. So what happens? What happens if chlorine comes in? It displaces the what? The sulfur and takes up the position. So originally sulfur belongs to hydrogen, but when chlorine comes in, who takes over? Chlorine takes over. And now hydrogen belongs to chlorine. And the sulfur is sent to also go under sulfur diaspora. And that's what it means to be unbonded. So you can guess. So what do you think will be seen? An observation, what can be seen? This one, hydrogen sulfide, is a colorless gas. Now you are trying to bring in chlorine. What do you think will be the product of this reaction? Displacement now. Displacement. Yes. So a displacement reaction. So, and some, okay, as you are figuring out, hydrogen chloride, is it hydrochloric acid? Hydrogen chloride, an acid. Let's look at the definition of an acid. What is an acid? A substance which, when dissolved in water. Hydrogen chloride is a gas. It is an acidic gas. But when dissolved in water, it produces hydrochloric what? Acid. So we shall see. It is not an acid because it doesn't have hydrogen ions in gaseous state unless when dissolved in water. So hydrogen chloride is what gives us hydrochloric acid. At the right time, we shall see. So that one is a question that has been asked by Nalomansi Emily. That is good, interactive. So please ask the questions. I have somebody who is going to answer this question. Hydrogen sulfide by plus chlorine. What do you think will be the products? Use be louder so that you can be heard.
Hydrogen chloride and sulfur.
The student has said hydrogen chloride and sulfur. Let us see. She is extremely very bright. So hydrogen sulfide, which is a gas, you pass chlorine through it, which is also a gas. She has said hydrogen chloride. So this is HCl, and it is what? A gas. She said plus sulfur. What's the physical state of sulfur? Physical state, be louder so that you can be heard. Physical state of sulfur is a solid. So what is the color of hydrogen chloride? White fumes. So what do we see? The pale yellow gas reacts with a colorless gas to form white fumes and a yellow solid. So these are white fumes and this is yellow. So what has happened here in this reaction? A displacement reaction has taken place. Our equation is not balanced. There are two hydrogens here. There is one hydrogen. We have two chlorines. There is one chlorine. What did we say? Make the odd numbers what? Even. So to make them even, what we do? We shall put a 2 here. And when we do so, I think the equation becomes balanced. So what have you captured in these reactions? That anything that has hydrogen also always be what? Removed by chlorine because of the high love chlorine has for hydrogen. Therefore, wherever you are, I want you to write down the equation for reaction between chlorine and ammonia. Chlorine will always remove hydrogen. So wherever you are, write the equation for reaction that you can compare between ammonia and chlorine. So your assignment is this is ammonia, and ammonia is a gas plus chlorine. And chlorine is a gas. What do you expect it to form? I'm giving you 30 seconds and we shall compare. Shamsa says, what forms hydrochloric acid when? What forms when hydrochloric acid? What forms when hydrochloric acid is mixed together with? The equation is not very clear. Can you rephrase your equation so that I can respond? When hydrochloric acid is mixed together with, there is something that you have not completed, so I may not be in position to give the answer. Please, Shamsa, you rephrase your question so that we can get meaning out of it as we continue. The 30 seconds I've given you, my dear students, are over. So, what are the products? What are the products? Yeah. You are free to send the message. Send the message quickly so that I can read. If you have already gotten the right answer, the products. I'm writing the products. Remember, I said chlorine will always remove hydrogen. Chlorine will always remove hydrogen. So, a combination between hydrogen and chlorine, what does it give? It gives hydrogen chloride. Physical state, gas. What is left to suffer also? Nitrogen. You also go out. But nitrogen is written as N2. It's a diatomic molecule at room temperature. So, is the equation balanced? One nitrogen, two nitrogens. Odd versus even. So we said we try to make the odd what? Even. So if here it is a 2 and here it is a 1, what does it mean? We multiply this by 2. Nitrogen has become 2, nitrogen is now 2. Our biggest challenge now is going to lie on hydrogen. Hydrogens have switched themselves from 3 times 2 to how many? 6. But here we have only what? 1. So what do? We shall put a 6 there. Okay, chlorines are now the big problem. How many chlorines are here? 2. How many chlorines are this way? 6. So what do? Which number should we multiply by 2 so that we get 6? 3. So put the 3 here. So that's the equation. What's the color of ammonia? Colorless gas. Yellowish green gas. What's the color of hydrogen chloride? White fumes, white smoke. What's the color of nitrogen? Colorless. Around you there is air, there is nitrogen. Are you seeing it? No. So which observation do you make in this reaction? The pale yellow greenish gas is going to give out white fumes. What are the white fumes? Fumes of hydrogen chloride gas. You breathe in this gas, it straight away turns into hydrochloric acid along the alimentary canal and it causes burns resulting to formation of ulcers, wounds. So it's very soluble in water. As somebody asked, Normancy asked, that is how hydrochloric acid is formed. We shall discover later that this gas is also as very soluble as ammonia in water. So it's very dangerous to inhale this gas. It turns into hydrochloric acid instantly as you breathe it in because of the moisture that we have. So, for the meantime, this is the standard equation I want. However, you'll discover in the notes as you read it in detail that now this gas is an acidic gas. It will go ahead and then react with ammonia to give us something else, which is called ammonium chloride. But this is a reaction that is going to be secondary. The prime reaction is this one. Though, after some time, ammonia will react with the hydrogen chloride. And what shall we form? We form a compound which is called ammonium chloride, which is also seen as white fumes that turns into a white what? Solid. All right. Somebody is saying, Kayondo, dear Kayondo, you are saying, what is the difference? I'm asking the question on his behalf so that everybody can hear. What is the difference between hydrochloric acid and hydrogen acid? Hydrochloric acid. Maybe you wanted to say hydrochloric acid and hydrogen chloride.
Yes, chloride.
So hydrochloric acid is physical state is aqueous, is dissolved in water. Hydrogen chloride is a gas. When you talk about a hydrogen acid, an acid is something that gives hydrogen ions. So all acids have hydrogen in them. Any acid you think of has hydrogen in it, but this hydrogen is only released as an ion in water. That's why we say an acid is a substance that releases hydrogen ions. But hydrogen as a gas is not an acid. So there is a difference between hydrogen and hydrogen ions or hydrogen ion. A hydrogen ion signifies acid. Hydrogen can be an element. And alone as hydrogen, it doesn't have acidic what? Properties. Unless it changes from a hydrogen atom to a hydrogen ion. So allow me expound on this, on Kayondo's question using senior 1 chemistry. That is a nucleus. And the nucleus has protons and neutrons, electrons outside. And this is atomic structure for hydrogen atom. A hydrogen atom like that. Because hydrogen is H1, one proton, and therefore one electron. Now when you talk about a hydrogen molecule, is where another atom of hydrogen comes and contributes also an electron. Therefore the two will combine to give you what we call a hydrogen molecule. So there, Kayondo asked the question, that is a hydrogen molecule. It has no acidic properties at all because merely sharing what? Electrons. Now when you look at a hydrogen ion, this is a hydrogen ion. A hydrogen ion comes from a hydrogen atom when this electron is lost or is given out. It is given out. And therefore, what do we end up with? We end up with the hydrogen ion where there is a nucleus and the energy level has no electron in it. And if you remember in our discussion, we agreed that once an electron is lost, you end up forming a positive ion called what? A cation ion. And since hydrogen has lost one electron, it has changed to a hydrogen ion, H+. And for it to be an acid, it must be when it is dissolved in water. So this is a hydrogen ion. This is a hydrogen atom. Hydrogen ion has acidic properties. Hydrogen atom does not have acidic properties. When does it get acidic properties? When the hydrogen gives out its electron to chlorine, or it combines with a radical, senior 2 chemistry like sulfate, nitrate, and so on. So that is what it means. I want us to conclude on our property of hydrochlorine with hydrocarbons. Now there is a hydrocarbon which is C, let me say 4, H10. This is a gas. Now you are adding the chlorine to it, which is also a gas. Predict the product. Think about the product. 10 seconds about the product. The first product, what is the first product? The first product is hydrogen chloride, and hydrogen chloride is a gas. What's the second product? The second product, yeah, wonderful. That is good. The first product, second product is carbon. So what is the color of hydrogen chloride? White fumes. What's the color of carbon? Black. So what do you see? White fumes and a black solid. Reduction has taken place. Now, they can confuse you with so many compounds, calling them very complicated names. Organic chemistry. What is the name of this compound? 4 carbon atoms. 4 carbon atoms. We said meth is 1 carbon atom. Eth is 2. Prop is 3. But is 4. Now, which formula is this? It occurs CnH2n plus 2. If C is 4, what is H? It is 2 times 4. That gives what? 8 plus 2 gives 10. And we say this is saturated hydrocarbon called an alkane. So, I mean, the question can come from alkanes, it can come from alkenes, it can come from alkynes and complicated compounds. Commonly used, which students pass very well, is what they call turpentine, which is C10H16. I know this one students pass it very well. Now you convert this one into that one, it becomes difficult. I don't know why. Of course, we are not balanced our equation. How many carbons are this? 4. How many chlorines are this? Hydrogens are this? 10. Therefore, what do I write here? 10. So how many chlorines are these? 10. How many are these? 2. Which number do I multiply by 2 to get it? 5. Now, why do you pass this one for turpentine? It is very complicated. And you fail the one that you are supposed to be knowing between carbon 1 and carbon 4. So what's the product here? So chlorine. So what shall we get? Hydrogen, chloride. What shall we get? Carbon. So how many carbons are they? 10. How many hydrogen are they? 16. So how many chlorines are these? 8. This one, people pass it. It's cram work because I've crammed the note, turpentine. Now you take it up with something else and say, no, that one is not possible. This one people pass, that one you can't. So today I'm deleting this. I even don't talk about turpentine. Let me talk about a simple alkene, ethene. What is ethene? C2H4. So plus chlorine. So what shall we obtain? Hydrogen chloride plus carbon. So how many carbons are they? 2. How many hydrogens? 4. So chlorines? 2. Simple things. The information remains the same. However, the reaction of this compound called turpentine is very explosive. It's very explosive. This one is very reactive. Very reactive. It has so many unsaturated bonds. Remember in organic chemistry, CR3, what did we agree? That alkynes are more reactive, alkenes are also more reactive, alkanes are not reactive because they're made up of single bonds only, which means this compound has quite many bonds that are not single bonds. That's why it is actually very reactive. So, when you check, for those who have printed in the notes, I want to refer to your work. For those, and I ask you to print. So, reaction number 5 was the reaction of the hydrogen chloride. Roman 2, there was a reaction with ammonia, which you have already seen, though it has extended work. You leave reaction 3 first and go to reaction number 5, 4, which reaction with the hydrocarbons. And we are quoting that compound. So let the things not disturb you. Turpentine. You think of simple things and transfer the work. So I'm saying the reaction, a red flash by a violent reaction to form black particles of carbon and white fumes of hydrogen chloride. And you have seen it, you have written the equation with a lot of what? With a lot of ease. And so on. So I organize this under oxidation reaction. So there is one oxidation reaction which does not involve hydrogen. My work is to break down the notes into simple things that you can understand. That is what we call teaching. However, there are other oxidation reactions that will come in later and so on. So I want for the time being to suspend the reaction between chlorine and iron 2 because there is no connection between iron 2 and hydrogen containing compounds. But it's also an oxidation reaction, which is coming in last. That's why I've skipped it first. And I'm going to look at it later. So now, allow me to conclude on that reaction with chlorine being an oxidizing agent with what we call iron 2. And this is part of the qualitative analysis that we are supposed to be looking at to continue because we had introduced. If you remember very well, what did we agree is the color of iron 2 compounds? If you remember very well in qualitative analysis. Meanwhile, you are free to text your questions that we can respond to them. We are supposed to be interacting. The color of iron 2 compounds is green. I know you have forgotten quantitative analysis. And we classify the compounds, those that are white, those that are green, those that are blue, those that are brown. We classified all of them. We said ZAP, CM are white. We say the copper compounds are either green or blue. We say iron 2 compounds are green. Iron 3 compounds are brown. So iron 2 is green. Iron 2 can easily change to iron 3. What's the meaning of iron 2? Iron in the valence of 2 and iron in the valence of combining powers. It has 2 valences. So, when iron 2 changes to iron 3, we say oxidation has taken place. So, we define oxidation in terms of 3 references. Reference number 1, oxidation is addition of oxygen. Are we adding oxygen here? No. Are we adding oxygen here? No. Oxidation is defined as removal of hydrogen. Do you see why you said oxidation reaction up there? What was being removed? Hydrogen. Are we removing hydrogen here? No. But we have just seen oxidation reaction with hydrogen containing compound. The definition of oxidation is removal of electrons. Electrons get lost. Electrons get what? Lost. So 3 definitions of oxidation. Addition of oxygen. We don't see an oxygen being added here. Number 2, removal of hydrogen. Iron 2 doesn't have what? Hydrogen. Number 3, removal of electrons. Maybe, let me bring you on board and you tell me what's going to happen. You remember in Sigma-2, that is sodium, atomic number what? 11. Electronic configuration, 2 to 8 to 1. Is it a metal or a non-metal? It's a metal. Which group? Group 1. Why group 1? 1 electron in the outermost energy level. Which period? Period 3. Why period 3? 3 energy levels. First energy level, 2 electrons. Second energy level, 8 electrons. Third energy level. Now, what is an ion? A charged particle. How an ion is formed? Either by gaining or by losing electrons. This is a metal. How do metals form ions? They form ions by losing electrons in the outermost energy level. So how many electrons are present here? 1. How many will be lost? 1. I have 1 shilling to spend on break is what I can. So what will be the end result? We shall end up with the sodium, and the is going to change from 2 to 8. The electron has been lost. But this sodium acquires a positive charge. Metals form cations, and the cations are positively charged. So how many electrons were lost? 1. Isn't it? So how many charges are formed? 1 positive charge. So the number of positive charges to the number of electrons that have been what? Lost. But the idea is that sodium has 11 protons and has 11 electrons. Isn't it? Why is it not charged? Protons are positive, electrons are negative. When you add it, what do you get? 0. That's why you don't see a charge here. So why do we have a plus 1 here? Now, in this sodium, how many protons? Protons have remained what? 11. We don't lose protons. They're in the nucleus. All right? What is being lost? Electrons. How many have been lost? 1. How many have remained? 10. So 10 electrons have remained. So mathematically, positive 11 when you add negative 10, what do you get? Positive 1. That's why you see one positive charge. So it's a sodium ion. What about if it was magnesium? Mg, which is 2 to 8 to 2. So what shall we form? Mg2 plus, because shall lose these 2 electrons. Are we there? So what is the meaning of this now? How many electrons had gotten lost? 2 electrons had gotten lost. Isn't it? What is the meaning of this now? 3 electrons have gotten what? Lost. The equation is balancing in terms of elements, iron, 1, 1, but the charges are not. So what do I do to remain with the 2 positives here and the 2 positives this way? I'll add an electron. This electron has gotten lost. The electron had been struck off, it has been removed. I'm striking 1 electron from this one. So it goes 3 plus. This electron has been picked away. So iron 2 has been oxidized to iron 3. And the color changes from green to brown, reddish brown. It's one thing in the lab for us to make us know that iron 2 has turned to iron 3. So during analysis of these compounds in the lab for practicals, you don't need to keep iron 2 compounds long. They'll get oxidized by air. This time it will be by air. And so on. This is what I'm trying to bring to your notice. So who has done this? There are so many things that can do this. Hydrogen peroxide, the one for treating wounds, pierced ears, and so on, can do it, an oxidizing agent. Oxygen in air can do it. Chlorine can also do it. Chlorine can also do it. So how can chlorine do this? Now, once this electron have been lost, what happens? Chlorine picks them. It prompts it to lose. Then somebody say, go home, go and steal. Go and steal, man, and bring it for me. I prompt you to go and steal the man and to bring it to me, which is a bad thing. You go into the fridge and remove a soda and bring it for me. You could have not given, but because I was saying to you, go and bring it for me. These things happen at home. Please get on something. I'm making it get oxidized. So chlorine is written like that. So, but this one is giving out only 1 electron. But these are 2 chlorines. So how many electrons should we need this time? We shall need the 2 electrons. And this one is giving only 1. So what shall we form? Once you gain an electron, what happens? You become negatively what? Charged. And therefore, we form a chloride ion. This equation is balanced. Now, my biggest challenge is these 2 are not the same. This one wants 2 electrons, for you are giving 1. So what you do? I want to add these 2 together. So what do we do here? You can give out only 1 soda, but I need 2. So what happens? I pick 1 soda from you, and I pick another soda from another person who is like you. So what do we do in such equations? You make sure that electrons are equal. This is mathematics now. Quadratic what? Is it simultaneous? I don't know. Simultaneous equations. So what do you do with simultaneous equations to remove a common factor? You must make sure the common factor is the same. So what you do? Look at the 2 equations, multiply by certain numbers to make that common factor what? Equal. This is simultaneous equations in mathematics. So there is simultaneous equations in chemistry. Chemistry, physics, math. I say to marry them together. So, math now. So this is 1, which is a common factor, electron and electron. So what we do? We make the 2 electrons what? equal. So what shall we do? We shall multiply equation 1 by 2 and equation 2 by 1 also becomes what? A 2. Having done that. This one remains 1, 2, 2. So when we add this together, what will happen? These ones will be found on the other side. We now remove them in mathematics. Because if I add the 2, I'm going to get 2 Fe2 plus, I'm adding this one, plus Cl2 plus 2E, giving us 2 Fe plus 2E plus 2 Cl minus. And all of these are in solution now, aqueous. This is aqueous. Chlorine was a gas. This is aqueous. So what do we do in mathematics? Common factor, cancel. My usual style. This way, that way, I taught it. So, I taught it this way, I taught it that way. And what is I taught it? You remove. In the chemistry, I refer them as spectator ions. So for me, I call them atomic ions. This way, that way, I taught it. Remove. So atomic comes, atomic goes. Clear them. It's a balance equation for the reaction, showing that chlorine is an oxidizing agent. It converts iron into iron 3. It's the basic idea, but I expect you to know. So looking at the amount of time that we have, which is something to do with about 10 minutes or so, I'm going to condense the remaining properties into general one concept. Then when we meet next, we can summarize. In the next property, I want to look at the reaction between chlorine and metals. It is also oxidizing, by the way. It's an oxidizing property. So reaction between chlorine and the metals. Allow me to remove this one. Reaction between chlorine and the metals. There are certain things that without a teacher you can do. Where is chlorine? Other side of the periodic what? Table. Where are metals? This side of the periodic table. There are things that are obvious. There are things that are obvious. Can you tell me why in our school boys sleep on a different side and girls sleep on a different side? These two are opposite one another. So what will happen if we mix boys and girls sleep in the same dormitory? In discipline. That you know. You have heard, you have seen. People will begin to pair up against the school rules. Not at this time. Until you have left the school. So pairing in Kibuli is punishable by expulsion and exclusion. Why? It's because these are two different people. Male versus female. So the predator has males and what? Females. What are the males? The metals. What are the females? Non-metals. And the chlorine is one of the females, one of the non-metals. So what do you expect? An obvious reaction to take place. For us, we are protected by religion and by school rules. So do you know why our sitting arrangement in the class is that boys are supposed to be sitting different from girls unless it is not, unless it's unavoidable? Those are the issues. We are avoiding reactions. Same here. So what happens? The general equation is a metal plus chlorine. What do you get? You get a metal what? You get a metal chloride. The name of the metal chloride is determined by the name of the metal. Oh yeah. There are many guys. Secondly, doing matovu. But the other one is chloride. Secondly, chloride. Matovu chloride. The way you see sometimes people dropping their names and taking up the names of the what? Of the others. So metal chloride. Ukenya chloride. Kiwanuka chloride. And so on and so forth. Myself chloride. So what do you know? You need to just look at the what? The metal. And you get the chloride. And if you know the values of the metal, you can write the equation. Group 1 metals, what are they? Do you see hydrogen comes back? Do you see sodium following? No. Lithium following. Do you see potassium? No. After potassium is sodium, and you see potassium. Have you seen there is beryllium here? And have you seen there is magnesium? And have you seen there is calcium? Have you seen there is aluminium? What about those outside the periodic table? There are other metals outside the periodic what? Table. What are they? Zinc, there is copper, there is lead, and so on. There are many. There is iron. You get it? So what do you think is the name here? Chlorine and hydrogen. Hydrogen chloride. Metal chloride. Lithium chloride. Sodium chloride. Potassium chloride. All of these reactions are very dangerous. Very explosive. You don't need to hit them. They two come into contact like this. Explosive. And this is what we call in the chemistry direct what? Combination. Direct synthesis. So we cannot prepare sodium chloride directly by combining because the reaction is very dangerous. However, this is okay. So this one can even take place in the dark. Some of this you need to heat. So as you go from group 1 to group 2, the element of heating and burning comes in. So with these metals, burning is required. Even in this one, burning may be required. Especially for aluminium chloride. Do you know the formula of aluminium chloride? Aluminium has a valence of 3. Chlorine has a valence of 1. Interchange. What do we obtain? AlCl3. What about zinc? Valence 2, chlorine, valence 1, interchange. Of all of these, you can write down the correct equation. Our biggest problem is iron does not give iron 2 chloride. It only gives iron 3 chloride. Why? Because chlorine is a powerful oxidizing agent. Iron 2 is very unstable. It changes to iron 3. So what remains are simple primary things to play about with you, not anything else. Last year there was a question between chlorine and magnesium. In last year, so say what will be observed? So there is a question between magnesium and chlorine. So what is the color of magnesium? Gray solid. This is pale yellow, greenish gas. So what do we form? We shall form magnesium, valence 2, chlorine, valence 1. And this is a solid. The reaction, these are seen as white fumes that will now settle down to form white what? Solid. And requires burning. So what will be the observation? The gray solid burns with a pale yellow flame to form white fumes that settle into a white solid. And that was a question for among last year. It was there. And it was quite a few questions and so on. So what about if it's iron? By the all of them first give white solid that later on can turn color if these compounds are transition elements. This one is clear. So there is only some that require diagrams of preparation where when you look at the notes, the diagrams are there. But this is the basic idea of what is going to happen. So if you can write the equation and balance it, then it is okay. So looking at one thing is applicable to the rest. Zinc chloride, copper 2 chloride, lead 2 chloride, iron 3, but not iron 2. Why iron 2 is unstable. Calcium chloride, magnesium chloride, all of these burn. So only this one burns with a green flame. The rest, yellow flame, form white solids. Other than iron 3 that will form a white solid that will turn later on into a brown solid. Period. So about metals, it is done. So in your notes, you'll discover that the work may not be the same the way we have looked at here. Here I'm giving general knowledge to help you write because we must continue. But that's the basic idea. So let's briefly check what is that. Make sure that what you have is what I want you to have. And we conclude with our session. So we are left with now displacement reactions only, which we shall conclude with. But you can see reactions with the metals. Dutch metals, those are things just confuse you. What you know is a metal. Whatever name of the metal is not the major thing. As long as you know the name of the metal, then you can get the name of the what? Of the chloride. And so on. Right. So in our discussion, we shall be discussing reaction of chlorine this time with what? With nanometals. We are left with nanometals and left with displacement reactions. I want to call upon you to read your notes on reaction of chlorine with metals, and when there is a problem, as we meet during our next interaction, we can be in position to review. I want to beg that as we interact those with the questions, you try as much as possible to forward so that we can respond. I want to appreciate the 5 students who have been contributing in the studio, and the 3 have been contributing online. That is Shamsa, Kayondo, and Narumansi. May the rest copy a link from those two so that we can continue. I want us to interact. Where there is an issue, please raise so that we can be patient to handle it. So go and read through reaction with nanometals and displacement reactions. In displacement reactions, we have only 2 issues. Displacement involving potassium iodide and involving potassium what? Bromide. But the idea here is simple. The more powerful you always displace, the less powerful. A senior 3 will displace a senior 2 and a senior 1. But a senior 1 never displaces a senior 3 or a senior 4. So that is the idea. So thank you so much for attending the lesson. Please, let's continue fighting, working harder. I still want to remind you, many people are dying outside. Don't go outside your home. And when necessary to go, if it's necessary to go out, please wear a mask. Don't touch wherever anything you come across. Wash your hands, sanitize. Stay safe until we shall meet. Assalamu alaikum wa rahmatullahi wa barakatuh.